So now I'm just going to go through the two examples I did not have a chance to do in class today. So for this first example, we're given three vectors, u, v, and w, and these are in component form, you'll see. And we're asked to find essentially the dot product of two pairs of the vectors. So the first one is dot product of u and v. Since these are in component form, I'm just going to go ahead and use the component formulation of the dot product, which is just this is u. We want to dot that with v, which is 4 comma 2. And again, the definition of the dot product is just going to be, I'm going to multiply the x components. So here we have the 3 and the 4. That's the multiplying of the x components. And then we're going to add to that the multiplying of the y components, negative 6 and 2. Add those together to get 12 minus 12 is 0. The next one is v dot w, and that's just going to equal the vector 4, 2 dot product with negative 12, 6. And again, we multiplied the x terms together, so we have 4 times negative 12. To that, we're going to add the multiplication of the y terms, which is 2 times 6. This is negative 48 plus 12 is negative 36. So we've done this first part here. Next, we want to show that u and v are perpendicular. Remember, the test for perpendicular is dot product equals 0 if they're perpendicular. We've already done the work here, so the dot product of u and v is 0. So yes, u and v are perpendicular because the dot product is 0. Because dot product 0. Okay, for the second problem here, I've just noticed that I actually have a typo in this example here. This vector w should actually be negative 12, negative 6. I'm going to go ahead and leave this example here alone, even using the wrong w, but for part B, it's going to be important to have the right w here. So we want to show that v and w are parallel. V equals the 4, 2 vector, and w equals the negative 12, negative 6 vector. So one way that we learned today to find if vectors are parallel is to see if one can be written as the scalar multiple of another. So the question is, can I find a k such that when I multiply it times vector v, which means I'm basically going to take v and stretch it out or shrink it or flip it and see if I can create w. So the question is that possible? So if I go ahead and multiply the scalar k through on the v vector, I get 4k, 2k equals negative 12, negative 6. And again, this is still a question. We're trying to see if we can find that k. Well, that's only going to be true if I get the same k for the y component or the x components, and the same k for the y component. So let's just solve each of those. Go x in red here. 4k equals negative 12, k equals negative 3. So the ratio of the x components looks like it's negative 3. And if we go ahead and do that for the y components, the ratio of the y components is, we have the 2k equals negative 6, k also equals negative 3. So these are proportionate. We found the same scalar that works for each of those components, and so that's how we know those are parallel. In fact, we can say that w equals negative 3 times the vector v is the way to what we just solved for there. We would not get, if these were not parallel, we would not have gotten the same scalar for both of those components. Okay, for this next example, we want to find the angle between these two given vectors. The vectors given are negative 1 and 2, and negative 1 comma 2 and 3, -1. Again, recall that the whole idea behind this lesson today was to use tools to find the angle between two vectors. So I'm just going to sketch these guys tail to tail to see what it is we're trying to find. So this first vector would be 1 over and 2 up. So approximately right there would be vector number 1. That's 1, comma 2. And then 3, 1 would be 3 over, 1, 2, 3, and 1 down. And I'm sketching these tail to tail. And so we're trying to find this angle theta. You know, just eyeballing it, it looks like it's going to be something around 90-ish degrees, maybe, you know, plus or minus, just based on the picture. Well, dot product, again, is a tool that we're going to use to find angles between vectors. And I like to think of starting with just the definition of the dot product, which, again, if you remember the idea that it's the multiplication of the two numbers that are taken in relative direction into account. So this first number, that vector u, is really, its magnitude is going to be the first number, and then that second number is the magnitude of v, which is how long that arrow is, and then we have to multiply that by the cosine of theta, taking into account the relative direction. So that's the way I like to think about the dot product when I'm not thinking about component form. It's the multiplication of these two numbers with this adjustment for the angle in between them. So then we can just use this formula or this formulation of the dot product to solve for cosine of theta, which would be the dot product divided by the magnitude of u times the magnitude of v. So then we just need those three pieces of information to find cosine of theta. U dot v is just going to be 1 times 3, multiply the x components, plus 2 times -1, multiply the y components and add them. That's going to be 3 minus 2 equals 1. So we have that piece. The magnitude of u is just Pythagorean theorem here. If we know that this vector is 1 over and 2 up, its length has to be 1 squared plus 2 squared equals root 5. And then the magnitude of the other guy is 3 over 1 down. That's going to just be the Pythagorean theorem again, which is going to be root 10. Cosine of theta, we have all the pieces, it's going to be, so the dot product is 1. And then these magnitudes multiply in the denominator, square root of 5, square root of 10. If you put that in your calculator, you get approximately 0.1414. Would be the cosine of the angle in between them. And then theta is just going to be the arc cosine of 0.1414, which is approximately 82 degrees. So theta is equal to 82 degrees. 82 degrees. And we use the dot product to solve that problem.